Hello everyone, I'm Paul and today we're solving problem 2901, longest unequal adjacent groups subsequence 2. This is a medium problem and this is the second part of a problem we solved recently. The video for that problem is in my channel, so I recommend you to go and watch it if you haven't. And I think this version is interesting and useful to practice dynamic programming, so keep watching. We're given a string array words and an integer array groups, and we need to return an array with the longest subsequence which meets these requirements. First, the elements in the array groups corresponding to adjacent indices in the subsequence have to be different. Next, the words in the subsequence need to have equal length. And next, the Hamming distance between words has to be exactly 1. And here we have the definition for the Hamming distance. Is the number of positions in which the corresponding characters in two words are different. So these are the three requirements, and now we will see an example. Let's say this is words and this is groups, and let's say that we take a subsequence with these and these elements. First, we are checking if the values of the corresponding indices at groups are different. In this case, we have a 1 and a 2 and they are different, so this is okay. Next, we need to check if the length of words is equal. In this case, the length is 3 and it's equal, so this is okay. And next, we are checking if the Hamming distance is exactly 1. In this case, the Hamming distance is exactly 1 because the only different character here and here is the first one. So this is 1 and then this is okay. So with this in mind, we can build a subsequence with BAB and CAB, and this has a length of 2, and 2 happens to be the longest valid subsequence that we can build in this example. Now we can also take BAB and DAB, and if we check the conditions, first the corresponding values in the array groups are different, they are 1 and 2. Next, the length of the words is equal, so this is okay and this is okay, and the Hamming distance of these two words is exactly 1 because the first character is different. This means we can also build a valid subsequence with BAB and DAB, so we can return this or this, both are valid. Now remember, we need to find the longest subsequence, so we can iterate this from left to right and keep track of the longest subsequence that we can build each time, and we are doing this with dynamic programming. So next we'll see how can we solve this with this approach. Now first we will create a DP array, and for each index we are creating an array which will include the corresponding word for that index initially, and we will iterate these two arrays with two pointers, I and j, and at each step we are first checking this. So for example, first we are checking if the values, the corresponding values in groups are different. In this case they are, so this is okay. Next we are checking if the length of these two words is equal. In this case it's equal, so this is okay. And next, the Hamming distance between these two words is exactly 1 because the only different character is the first one. So this is also okay. And we need to check something else. Up to this moment, we know that this is a valid subsequence. But remember, we are trying to find the longest valid subsequence. So let's say we add this here. We will have something like this. And now we need to ask ourselves if the length of this array is bigger than the length of this array, and in this case it is bigger, so we are replacing this array with this one. So now dp at j equals to this array, and each time we are updating I up to j, so in this case we need to update j one step to right. Now j is here, and we are first checking if this value and this value are different, and they are, so this is okay. Next, the length of these and these words are equal, so this is okay. And next, the Hamming distance of this and this is exactly 1 because of the first character, which is different, so this is also okay. And next we are checking if this array with this string has a length greater than this array. So if we add here CAB, this has a length of 2, and 2 is bigger than a length of 1. So in this case we replace this with this. So now this is dp at j, and we update I one step to the right. Next we update I, and we are checking if this value is different from this value, but 2 equals 2, so this is not true. Finally we update j, we reach the end, and this is the final dp array, and from here we can return any array with the biggest length, so we can return this or this. And this is it for the approach. Now time complexity for this will be big O of n square, because we are iterating this with 2 pointers, times the maximum length of a string, which I think it's 10, but we can call this c, and space complexity will be roughly big O of n square because of this nested dp array. So now we will go with the code, and hopefully you will get the idea. First we'll say n equals length of groups, dp is an empty array, and for every word in words we are adding to the dp an array with the word. Next we are creating a function. We will call this Hamming. This is a separate function, and this will take 2 strings. We will call this a and b. In here we'll say n equals length a, count equals 0, and for I in range n, if a at I is different from b at I, count plus equal 1, and if count is greater than 1, we return false. So if at any point the count is greater than 1, we return false, and by doing this we are saving some time. Next we return count equals 1, so this will return true if the count is 1, or false otherwise. Next we will set a maximum value of 1 initially, because 1 is the minimum subsequence we can build, so that's why this is 1, and the result is initially an array with words at 0. Now we will say for j in range from 1 up to n, and for I in range from 0 up to j. Remember, we are iterating this whole thing from left to right, and I is to the left of j. Okay, and now we are checking if groups at I is different from groups at j, and the length of words at I equals the length of words at j, and Hamming words at I, words at j, and this is a very important part. If the length of dp at j is smaller than the length of dp at I plus 1, remember we are taking the array at dp at I and we are adding words at j. That's why here we are checking if dp of I plus 1 is bigger than dp of j. And if this is true, we update dp at j with dp at I plus an array which will contain words at j. Okay, this is how we can concatenate arrays in Python. We are building an array with only one element, words at j, and we are concatenating it with dp at I. And next, if the length of dp at j is greater than the maximum value, we update the maximum with length of dp at j, and we update the result, which is now dp at j. And finally, we return the result. So this is the entire code, and now we'll submit this and see if it works. And as you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.